Hello guys, so our experiment is determination of the rigidity modulus of the material of a metal wire by torsal oscillation method. Aim of the experiment is to determine the rigidity modulus of the material of a given metal. Now coming to the definition of rigidity modulus, it is also called as shear modulus. It is the measure of a material's ability to resist deformation under shear stress. It quantifies how much a material deforms when subjected to a force parallel to its surface. Hello guys, so this is the experimental setup of determination of rigidity modulus by torsal oscillation method. Coming to the setup, this is the metal wire, these two are the movable clamps, and this is the metal disc. Two magnets are attached to this metal disc. These two are the iron coils. So magnets are attached in such a way that they are parallel and in opposite directions. This is the signal generator. This is the power amplifier.
Let's see the connections of this experiment. Connect signal generator to the power amplifier. From here to power amplifier input. Then connect the wires coming from the coil to the power amplifier output.
Now let's see the procedure of the experiment. First, change the distance of the movable clamps from the center of the coil. Let's say if we need to keep the distance at 20 centimeters, the distance from center of coil to first movable coil is 10 centimeters and the other coil is 10 centimeters. Then total will be 20. Then now switch on the power supply. Switch to amplitude mode and keep constant amplitude, say some 2. Now switch to frequency mode. When we are increasing the frequency, we will observe the oscillation of the coil.
In this experiment setup, when the signal generator is turned and the signal amplifier is kept sufficiently large, the power amplifier sends a current through the two magnet coils in series. The coil will exert a force on the magnet fixed prongs attached to the central metal disc. This will exert a torque on the metal wire and will make it execute forced torsal oscillations at the frequency of the signal generator output. The central disc has a moment of inertia mr' by 2 about the axis of the wire.
Now coming to the tabular column, this is our tabular column, serial number, and this is the length from which we are keeping the mobile clamps from the coil. This is inverse of length. This is the frequency which we are noting down, and this is the square of the frequency. This is the tabular column. We have already taken our values. So when we take graph between x square versus 1 by L, it will be straight line. So find the slope of that straight line.
Let's find the moment of inertia. The formula of the moment of inertia is I equals to mr' square by 2 plus m dash L square by 2. R dash is the radius of the disc. The value of the radius of disc is 1.75 into 10 to the power of minus 2 meters. And L is the distance between two magnets. The value of the distance between two magnets is 6 into 10 to the power of minus 2 meters. M is the mass of the brass disc. Value is 42 into 10 to the power of minus 3 kg. And M dash is the mass of the magnet each. The value is 1.4 into 10 to the power of minus 3 kg. Next, coming to the calculation of the inertia. Already we seen the formula of inertia is I equals to mr' square by 2 plus m dash L square by 2. Now substitute these values in this formula. So the value of m is 42 into 10 to the power of minus 3 kg. 42 into 10 to the power of minus 3 kg. And r dash is the 1.75 into 10 to the power of minus 2. 1.75 into 10 to the power of minus 2. Here it is r dash square. So square by 2 plus next m dash. M dash is the 1.4 into 10 to the power of minus 3. 1.4 into 10 to the power of minus 3 into L square. L square is 6 into 10 to the power of minus 3 whole square by 2. Now by calculating this value, we are getting 8.95125 into 10 to the power of minus 6 kg meter square.
We have find out the value of moment of inertia, that is 8.9215 into 10 power minus 6 kg meter square. The formula to find
square L, where f square L is the slope of the graph between 1 by L and f square, which is the straight line. So from the graph we got the slope value as 47.35. When we substitute the value of pi